So as we saw in that last slide, the standard deviation is the measure of variation that we pair with a mean. And we use that when we're dealing with symmetric distributions. But what kind of a variation, like how do we calculate variations when we don't have a symmetric distribution? And that's where what we call the range. So the range is what we're going to use to find that variation with non-symmetric distributions. So the range tells us the spread of width of the entire data set. We calculate the range as the difference between the maximum, so that you take the maximum and you subtract the minimum value from that. And that tells you the range of values. So what we do is we'll end up, if we have non-symmetric distributions, we use the mean and the median, they get paired up to provide a measure of center and spread. Let's look at an example. Find the range of the following test scores: 100, 55, 82, 64, 61, 70, 71, 85, 74, and 78. We can see in this case our maximum value is 100. That's the largest value that these scores take on. The smallest test value is 55. So our minimum is 55. So to find the range, you take the maximum and you subtract the minimum value from it. So that's going to give us 100 minus 55, which gives us a range of 45 points. So another way that we can kind of take this range finding to use as a variation of the data and kind of make it even more, we can use what's called this interquartile range and the 5-number summary for figuring out the measure of data for a non-symmetric distribution. So the interquartile range, which sometimes you're going to see called IQR, is the width of the interval over which the middle 50% of data lies. To calculate the IQR, you need to first find the value that cuts off the lower 25% of data values, which we call quartile 1, and the value that cuts the upper 25% of data values, which we call quartile 3. So quartile 1, which we'll denote as Q sub 1, is the median of the lower half of the data. Quartile 2, or Q2, is the median of the whole data set. Quartile 3, or Q3, is the median of the upper half of the data. And so the IQR, which is called the interquartile range, is you take Q sub 3 minus Q sub 1. And that gives you that middle 50% of values, that spread of those. So let's look at an example. Find the IQR of the following test scores: 100, 55, 82, 82, 64, 61, 70, 71, 84, 74, and 78. So we already found the range of these, which was 45. And that gives us a pretty good value, or a good idea. However, if we really think about it, these aren't really spread out. If I'm looking even just like at between 82 and 78, those are all pretty close together. It's that 100 and that 55 value that's kind of bringing these, making the spread look a lot larger than, for the most part, it really is. So this is where this interquartile range really is helpful in getting a more idea about, or a better idea about the spread of the data. So to figure out the IQR, we need to figure out quartile 3 and quartile 1. So the first step is we need to put these into numerical order. So when I do that, we get 55, 61, 64, 70, 71, 74, 78, 82, 82, 85, and 100. So the first thing we need to do, so quartile 1 is the median of the lower half of the data. So I first need to figure out where's the lower half of the data. So the middle of these values, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 data points. So that's going to leave this 74 is the median that's going to cut that into 2 halves. So you can see there's 5 values below 74 and 5 values above 74. So that ends up being our median. All right, now I have my data split in a lower half and an upper half. So I'm looking at the lower half of data. The median of that is going to be 64. If I'm looking, so that's going to be our quartile 1. If I'm looking at the upper half of data, the value that falls in the middle, or the median of that, is 82. So that's our quartile 3. So to find that interquartile range, which we'll denote as IQR, what we do is we'll take 82 minus 64, and that gives us 18. That is a much kind of better idea of what the spread of the most of this data is. So this middle half of data, the spread is only 18 points versus looking at the entire range of the data set, which we got was 45.